Welcome to RoRe Academy YouTube channel 2.0. Our new and improved channel is dedicated to showing you how things are put together, from concept to prototype. Here, we break down the art of designing, assembling, and testing real engineering systems, helping you understand the science and creativity behind innovation in power electronic-centric systems and devices in our 5-minute video clips. Before we go into today's lesson, let's take a quick look at an incredible diagnostic tool that every EV engineer or enthusiast should know about, the AutoMaxi Ultra EV. This is a next-generation full-system diagnostic scanner designed for electric, hybrid, gas, and diesel vehicles. What makes the Ultra EV stand out is its ability to perform a comprehensive analysis of electric and hybrid vehicles, including advanced topology mapping and battery pack analysis. You can perform diagnostics via an OBD connection or directly through the included specialty cables and jumpers, perfect for in-depth testing of high-voltage battery systems. The 12.9-inch touchscreen tablet provides a clear, detailed view of your diagnostic results. Now, let's see how this powerful diagnostic tool is set up and operated in real time.
Our EV-related diagnostic software on our Ultra series of tablets. New Energy, green button. And this is going to be the button that you'd want to see. Quite a robust selection of vehicles that are EV software pack test. And you'll notice that once we connect to the car, it's going to give us a little bit of disclaimers, some high voltage safety related information. I'm going to go ahead and communicate with the vehicle. I'm going to select the blue button here that says battery pack information, and it's going to pull up a whole host of diagnostic information to help you repair that vehicle. So the first screen that comes up is our module status. You can see some overall general information at the top of the screen of different information about the battery pack, the state of charge, the state of health, the total voltage. But then at the bottom, we're going to see the infrastructure of how many modules this particular battery pack has. In every module, there are several cells. So if I have the button at the top of the screen that's called cell status. Cell status allows me to look at the individual cells of all the modules all at once. So I have a couple ways I can view it. If I hit the 4 little squares, it allows me to see all the actual voltages. The ones in red and blue represent the highest cell voltage and the lowest cell voltage from the battery pack, and it tries to balance them to be equal. At the top of the screen also, we have the battery pack info button. This gives me all the information that I need about this battery pack. Very helpful for, at the top of the screen, is the other live data button. So here is all the other data that the BMS, the battery management system, is allowing us to see all at once. And just like every other part of your diagnostic.
Hey guys, if you're into EVs or work with electric cars, you need to check this out. The AutoMaxi Ultra EV diagnostic scanner is seriously one of the best tools out there for deep dive battery diagnostics and full system testing on electric and hybrid vehicles. It's fast, accurate, and super easy to use. Honestly, a total game changer if you're serious about understanding your EV inside and out. So if you want to grab yours, just click the link in the video description below and check it out. Welcome back to the channel. Today, we're kicking off part 1 of an in-depth power electronics comparison between 2 of the most advanced electric vehicles on the road, the Porsche Taycan and the Tesla Model S. But instead of talking about motors or batteries, we're zooming in on the real brains of the powertrain, the inverter. This is the component that decides how efficiently power moves from the battery to the wheels, and it's one of the biggest factors behind acceleration, range, and overall performance. Porsche and Tesla take very different engineering approaches. One leans heavily into compact, high-density power modules, while the other pushes the limits of custom-designed discrete IGBT technology. So which design packs more power in less space? Which one runs cooler, switches faster, and delivers better torque response? Let's break down the technology, the packaging, and the raw power density in this Taycan versus Model S inverter showdown. The Porsche Taycan's front power unit delivers some seriously impressive performance. It produces around 240 kilowatts of continuous power and can boost up to 300 kilowatts at peak, delivering 345 Newton-meters of instant electric torque. On the road, that translates to a 0 to 100 kilometers per hour time of just 5.4 seconds, delivering that signature Porsche acceleration smooth, silent, and brutally quick. With a range of up to 431 kilometers on a full charge, the Taycan balances performance with long-distance capability. And thanks to Porsche's 800-volt ultra-fast charging system, you can recharge from almost empty to 80% state of charge in just 22 minutes. Its performance, efficiency, and cutting-edge engineering, all wrapped into one of the most advanced EV powertrains on the road today. The Tesla Model S delivers a blend of power, efficiency, and long-range capability. Its electric drive unit produces around 225 kilowatts of continuous power, with a peak output of up to 270 kilowatts, and an impressive 439 Newton-meters of instant torque. On the road, that means the Model S accelerates from 0 to 100 kilometers per hour in just 5.8 seconds, giving you that smooth, effortless EV surge Tesla is known for. Where the Model S really shines is range, offering up to 640 kilometers on a single full charge, making it one of the longest-range electric vehicles available today. And with Tesla's fast-charging technology, you can recharge to 80% state of charge in about 30 minutes at a supercharger. It's a combination of strong performance, incredible efficiency, and practical everyday usability, hallmarks of the Model S powertrain. In the Porsche Taycan Turbo and Turbo S, the compact front-axle powertrain is a masterpiece of electric engineering. At its heart is a high-performance permanent magnet synchronous motor using advanced hairpin winding technology. This allows tighter copper packing, lower losses, and incredible power density. On the Turbo S, this motor delivers up to 190 kilowatts and 400 Newton-meters of torque, while the turbo version produces 175 kilowatts and 300 Newton-meters. Spinning at speeds of up to 16,000 revolutions per minute, the entire unit weighs only 76 kilograms, making it both incredibly compact and astonishingly powerful. This is the kind of engineering that gives the Taycan its razor-sharp response and signature all-electric performance. The front axle uses a single-speed transmission in a coaxial layout, engineered for both power delivery and efficient energy recovery. It can handle up to plus 450 Newton-meters of torque during traction and minus 300 Newton-meters during recuperation. Inside, the transmission packs 2 planetary gear sets, giving it strong torque capability in an incredibly compact footprint. It's cooled through the electric motor's water jacket system, and the entire unit weighs just 16 kilograms, highlighting Porsche's focus on lightweight, space-efficient drivetrain design. A pulse-controlled inverter with 800-volt technology in 2 variants. 600 ampere in Turbo S, 300 ampere in Turbo and 4S. In the Tesla Model S powertrain, everything starts with a liquid-cooled AC permanent magnet synchronous motor, controlled by a variable frequency drive and connected to a single-speed fixed gear. But one of the most interesting engineering choices sits inside the inverter. Instead of using traditional power modules, Tesla opted for a more unconventional approach, paralleling 2 247 discrete IGBTs. 6 IGBTs are placed in parallel for each switch position, giving the inverter a total of 36 individual IGBT devices. This design lets Tesla fine-tune thermal performance, lower costs, and spread heat more evenly across the inverter. It also provides redundancy while still delivering the high current needed for the Model S's massive torque and acceleration. It's a clever example of Tesla's design everything in-house philosophy, pushing performance by rethinking even the smallest components. Inside the Porsche Taycan's powertrain, the inverter is a masterclass in compact, high-performance packaging. At the top, you'll find a single integrated electronics board that combines the cover, the control board, and the gate driver board all in one. Just beneath that sits the DC busbar, and below it are the 6 power modules, mounted directly alongside the DC link capacitors to keep switching paths short and efficiency high. Between the DC link stage and the inverter housing, Porsche inserts a dedicated EMI filter, ensuring the system meets strict EMC requirements despite operating at extremely high switching speeds. The current sensor is mounted at the AC interface, which connects directly to the inverter housing and the cooling radiator. This tight integration allows the inverter to manage heat, current flow, and switching performance with exceptional precision, supporting the Taycan's instant torque and ultra-fast charging capability. The Tesla Model S inverter consists of the control board, which is on top of a stamped metal shield. Under the shield is a plastic cover which retains the silicone gel potting compound that encapsulates the gate driver board. Bus bars are layered beneath the gate driver board, followed by the transistors and the DC link capacitor, which is at the bottom of the enclosure, furthest from the gearbox. Current sensing is provided by two Hall effect sensor ICs embedded in gap-soft ferromagnetic rings which surround two of the phase cables. Unlike all other inverters surveyed, Tesla has opted for paralleling two 247 discrete package IGBTs to achieve the required current ratings rather than using power modules. 6 IGBTs are paralleled per switch for a total of 36 IGBTs. Thank you so much for watching today's video and learning how the powertrains of the Porsche Taycan and Tesla Model S are put together. Remember, here at RoRe Academy YouTube channel 2.0 you watch, learn, and understand how to prototype. See you in the next video. If you found this video insightful, don't forget to like, subscribe, turn on notifications, comment, and share, so you never miss our next deep dive into the world of technology and innovation.